Hello class. Today I'm going to make a video for y'all because I'm not here, obviously. So you just got a homework worksheet titled 3.3.1 Exponential Growth and Decay. And I want to talk about this. Now it gives me two equations at the very top. It gives me f of t equals a times b to the t. And then it gives me a slightly modified f of t a times b to the kt. And I want to make sure that we focus on this one because this is the one we really want to work on. I kind of want to ignore this one for just a little bit. Okay? So looking at number one, it says a population numbers 11,000 organisms. And it initially grows, so, oh gosh, I can't read. So it grows with 11,000. I can't read, guys, I apologize. So I have 11,000, and we're growing at a rate of 8.5% every 3 years. That's key. That is super key. It's not every year, but every 3 years. So, let's talk about this. Well, if I grow 8.5%, a small calculation will show me that if I take, oh gosh, I can't write. Hold on. It's early in the morning. I'm literally doing this before y'all come to class. Bear with me. I take 11,000 and I multiply by 8%, 85%. I'm going to get 935. Okay? So what we know is after 3 years, we have 11,935 organisms. So I can kind of start to set that up. I have this equation that says f of t equals a times b. So I'm going to go with my new amount, 11,935, and we've been seeing it where it's always like the initial amount. So let's go with that trend. Equals 11,000. Now it gives me a b. Well, I'm going to pretend like that b stands for the letter r for rates. Okay. Again, I'm just kind of making some stuff up. But let's see what happens. And then I got a k. I don't know what k is, the constant. And then I have a t. Oh, wait a minute. Did I have a t? I actually did. What was my time? Very good. It was 3 years. I'm so proud of y'all. So I could write this as a statement, but I don't know what k is. And that's kind of a problem, but I can always solve for k. So I said we do. Let's peel off some layers. I'm going to divide by 11,000. And you guys, I highly recommend you calculator at your desk when you do this. And you'll get some cool answer. I just typed it into my calculator. And apparently it's 217 over 200, which whatever that is, a little bit more than 1, right? Is equal to 0.085 to the 3k. Now, I want to get that k down from the exponent, so I'm going to have to use a log. So we want to use a log of what base? We want to use a log of base 0.085 of this number. And again, this, I have a calculator. It's a powerful tool. It will tell me the answer. And that will now just equal 3k. That's the power of logs. If I type this into a calculator, I get some really big answer. I will tell you what that answer is. It should be like a negative 0.0, maybe a 3. I'm just going to go 3 for now. Equals a 3k. And I can now divide by this 3, and I can make a statement that my k value is equal to negative 0.011. So what does this mean? Well, this means that I can now create an equation. When we talked about this equation, t is equal to a times b to the kt. For my situation, with this problem that I'm working with, I can make the statement that f of t is equal, let's call it p for the initial population, times my rate r, all to the negative 0.011 t. And now I can find out how many organisms I have at any given time. And that's kind of cool. I think it's kind of cool. Now, that was one way to do this problem. We could have done this problem a different way. We could have did this problem and said, okay, I have 11,000, and I'm growing at a rate of 8.5% every 3 years. Well, if I'm growing, I could always use the popular equation, the one we've already kind of talked about. My initial population, 1 plus my rate, because we're growing. Do we agree? To the kt. Again, I haven't really changed anything. This is still that a value. This represents that b value. So it's all the same as my original equation. And then now I know I'm going to get this 11,935 is equal to 11,000 times, instead of 0.085, it's going to be 1.085 because we're adding the 1 to the 3 times my k. And we can do the exact same process as we did before, and we will find that k is going to be equal to just 1/3. Just 1/3. And that's kind of cool. So I could make the statements, I can make an or statement. I could say or, I could say my exponential growth model can be represented as this. Because it's t divided by 3, 1/3 times t. Either one of these would work. They're both the same exact equation. They'll both give us the same exact answer. I just get to pick and choose which one I like better. All right, guys, go ahead and work on this worksheet for the rest of the day. Talk together, work it out, work as a team, work as a group. I don't really mind. I want you guys to do the best that you can. If you have any questions, put it on Emoto. I will be here after school today, so come on by and see me if you have a question. Adios.